Assalamu alaikum and good day everyone. Today, we will continue with MLT423 Serology, Tutorial 2, entitled Quality Control and Quality Assurance in Serology. This topic is very important because serology results are used to help diagnose diseases, monitor infections, screen blood, and support patient management. As future medical laboratory technologists, you must not only know how to perform a test, you must also make sure the result is accurate, reliable, and safe to report. A wrong result can affect the patient's diagnosis and treatment, so quality is an important responsibility in the laboratory. By the end of this session, you should be able to explain the key concepts of quality control, quality assurance, quality assessment, accuracy, and precision in serology. You should also be able to describe the quality system and quality assurance cycle, including the pre-analytic, analytic, and post-analytic phases. Lastly, you should be able to apply QC and QA practices in serology, including proper specimen collection, reagent quality, control sera, and instrument calibration. So please remember that this topic is not only theoretical, it is closely related to daily laboratory practice. Quality control, or QC, is a process or system for monitoring the quality of laboratory testing. It helps us monitor the accuracy and precision of test results. QC also involves routine data collection. This means the laboratory collects and analyzes data from every test run or procedure to track performance over time. Another important point is that QC allows immediate corrective action. If an error is detected, the laboratory can take action before the results are reported. This is very important because every diagnostic decision made by a clinician is based on laboratory results. If the results are inaccurate, patient care may be affected. So QC acts as the frontline defense against wrong laboratory results, and it must be performed with every test run. Accuracy is the closeness of a measured value to the true value, affected by systematic errors. Precision is the closeness of repeated measurements to each other, affected by random errors. The ideal goal is for results to be both accurate and precise. There are three main types of errors in serology: pre-analytic, analytic, and post-analytic errors. Pre-analytic errors happen before testing and are the most common. Examples are wrong patient ID, wrong specimen, hemolyzed sample, poor storage, low sample volume, and request form mistakes. Analytic errors happen during testing. Examples are reagent problems, instrument errors, wrong incubation, pipetting errors, control failure, and test interference. Post-analytic errors happen after testing. Examples are wrong reporting, delayed results, missed critical values, wrong interpretation, and lost reports. Most errors happen before testing. Therefore, correct patient identification and proper specimen collection are very important. QC is the checking process done during testing to make sure the assay is working properly. QA is broader. It covers the whole process, from test request until the final result is reported. Quality assessment, or proficiency testing, checks whether the laboratory can produce correct results compared with other laboratories. SOP means standard operating procedure. It gives clear step-by-step instructions so that all staff perform the test in the same way. So QC is part of QA, and both are important in serology. A laboratory quality system has many components, such as personnel, equipment, documents, records, safety, purchasing, assessment, and improvement. The main idea is that quality depends on the whole laboratory system, not only the test kit. Even if the reagent is good, the result can still be wrong if the staff are not trained, the equipment is not maintained, or the SOP is not followed. So quality must involve the whole laboratory process. The QA cycle includes three main phases. The pre-analytic phase includes patient preparation, test request, specimen collection, labeling, transport, and receiving the specimen. The analytic phase includes the actual testing, QC, reagent checking, instrument checking, and correct incubation. The post-analytic phase includes result verification, reporting, interpretation, record keeping, and monitoring turnaround time. The important message is, quality starts before testing and continues after testing. This diagram illustrates the quality assurance cycle, emphasizing the flow from pre-analytic patient preparation to analytic testing and post-analytic reporting and record keeping. Now, we will explore the essential steps in designing a robust quality control, or QC, program. To design a QC program, the laboratory must first have clear SOPs and policies. Staff must be trained and competent. QC results must be recorded properly. This helps the laboratory monitor test performance over time. The laboratory must also set acceptable limits for QC results. If QC fails, corrective action must be taken before patient results are reported. Westgard rules are used to help interpret QC results. They help the laboratory decide whether a test run is acceptable or should be rejected. These rules can detect problems such as random error, shift, or trend. The main point is that QC results should be interpreted using proper rules, not by guessing. The Levy-Jennings chart is the base for Westgard rules. This chart plots control values against the run number, with lines for the mean and standard deviation to visually identify QC rule violations. Serological tests play a vital role in diagnosing infections, blood banking, antenatal screening, in vitro classification, vaccine monitoring, and epidemiology by detecting antibodies and antigens in the serum. Advantages of serological methods include rapid identification, high specificity, and simplicity. Limitations involve the window period in early infection, cross-reactivity, and the need for skilled personnel and equipment. Good laboratory results begin with good specimens. The correct test must be requested, and the correct patient must be identified. The specimen must be collected, labeled, transported, and stored properly. If the specimen is hemolyzed, lipemic, insufficient, wrongly labeled, or poorly stored, the result may not be reliable. So specimen quality is an important part of QA. Specimen quality assurance continues with correct transport and storage, maintaining the cold chain. Finally, specimen suitability assesses quality, rejecting unsuitable specimens, such as hemolyzed or underfilled tubes with documented reasons. Control sera are samples with known expected results. They are tested together with patient samples to check whether the assay is working properly. Usually, we use positive and negative controls. The positive control should give a positive result, and the negative control should give a negative result. If the control result is wrong, patient results should not be reported until the problem is solved. Good reagents are needed to produce reliable results. Reagents must be checked for expiry date, lot number, storage condition, contamination, and correct preparation. When a new reagent lot is used, the laboratory may need to compare it with the previous lot. Reagents must also be stored at the correct temperature. If reagents are poor or expired, the test result may be wrong. Equipment must be properly maintained and calibrated. In serology, equipment may include pipettes, centrifuges, incubators, refrigerators, freezers, washers, and readers. For example, if a pipette gives the wrong volume, the test result may be affected. If a refrigerator temperature is not correct, reagents may become damaged. So equipment monitoring is an important part of quality assurance. Documentation is very important in the laboratory. A common saying is, if it is not documented, it was not done. Records include QC results, equipment maintenance, reagent logs, SOPs, incident reports, training records, and corrective actions. Documentation helps the laboratory trace problems and prove that procedures were performed correctly. It is also important for audit and accreditation. If QC fails, patient results must not be reported. The laboratory must investigate the cause. We should check the reagent, instrument, control material, technique, incubation time, temperature, and possible human error. After the problem is corrected, QC must be repeated. Only when QC is acceptable can patient results be released. Let us summarize the main points. QC checks whether each test run is working properly. QA covers the whole testing process, from specimen collection to result reporting. Accuracy means the result is correct. Precision means the result is consistent. Most laboratory errors happen before testing, so patient identification, specimen collection, and labeling are very important. Control sera, good reagents, calibrated instruments, SOPs, documentation, and corrective action are all essential for reliable serology results. That is all for today's lecture. I hope you now understand that quality in serology is not only about performing the test, it is about making sure every step is done correctly and safely. Before we end, think about this question. If QC fails during a serology test, should we report the patient results? The answer is no. We must investigate, correct the problem, repeat QC, and only report results when QC is acceptable. Thank you, everyone.